So let's look at another problem where we try and find all the roots of a polynomial. All right, so here is our polynomial, our cubic polynomial. Now I happen to know from the start that because it's a cubic polynomial, if I find one root, then I'll be able to divide that root out and end up with a quadratic. So it really only takes finding one root, and then I can finish it out by just finding the roots of a quadratic, which is relatively simple. If I had started with a fourth degree polynomial, quartic, then I might have to find one root, reduce it to a third degree cubic, find another root, and then get to my quadratic. So it can be quite a few steps. With the with the cubic, it won't be too bad. I really have one root finding, and then I'll find the others through the quadratic formula. Okay, so I take a look at this polynomial, and I see that it has a leading coefficient of 1, and it has a constant coefficient of -8. So I want to look at the factors of -8 and the factors of 1. And I'm going to be putting these factors of -8 over the factors of 1. All right, so the factors of -8 and the factors of 8 are the same. That would be plus or minus 1, plus or minus 2, plus or minus 4, and plus or minus 8. The factors of 1, that's simple. That's just plus or minus 1. So then I get my possible rational roots by putting all those factors of 8 over each of the factors of 1. So plus or minus 1 over plus or minus 1, plus or minus 2 over plus or minus 1, plus or minus 4 over plus or minus 1, and plus or minus 8 over plus or minus 1. Now doing them over plus or minus 1 is really a silly exercise, but I'm just making the point of how we're doing it, because that just creates a lot of duplicates. Meaning plus or minus 1 over plus or minus 1 really just gives me plus or minus 1, and the same thing for all of them. Okay, so there, I have my possible rational roots without any duplicates. So I see that there's 8 of them, 2, 2, 2, and 2. And so I'm going to go through and I'm going to just try them. So I'm going to try 1 by doing f of 1. That gives me 1 cubed minus 8 times 1 squared plus 16 times 1 minus 8. Go ahead and calculate that. That'll give me 1. Okay, not a root. All right, let's go to -1. -1 cubed minus 8 times -1 squared plus 16 times -1 minus 8. Calculate that, you get 33, not a root. So let's go to 2. F2, 2 cubed minus 8 times 2 squared plus 16 times 2 minus 8. Calculate that. Oh, we get 0. There, we've done it. Root. Okay. This again, that's just coincidence that we got 2 again as the last problem. But x equals 2 is a root, and x minus 2 is a factor. Remember, it's always x minus the root. So if we had found -1 was a factor, then x plus 1 would be the, if we found -1 was a root, x plus 1 would be the factor. Okay, so once we have this, and we know that x minus 2 is a factor, we divide that into our original polynomial. X cubed minus 8x squared plus 16x minus 8. So the x minus 2, so to get from x to x cubed, I need an x squared. So x squared multiply x cubed minus 2x squared subtract, we get minus 6x squared, bring down the plus 16x. X to minus 6x squared would be a minus 6x, giving me minus 6x squared plus 12x. Subtract. That's going to give me 4x, bring down the minus 8. X to 4x is a plus 4. So that gives me 4x minus 8. And I get 0. Again, I better get 0 because I've already said x minus 2 is a factor. So I really have to get 0 here. If I don't, I should check that I made a mistake. All right, so where are we? So now I can say that this f of x, this original x cubed minus 8x squared plus 16x minus 8 can be written as x minus 2 times x squared minus 6x plus 4. All right, so I already know that's where the 2 is coming from. My other two factors are in there. This time, it's not going to factor so nicely. So using the quadratic formula, 6 plus or minus the square root of 36 minus 4 times 1 times 4 over 2 times 1. You're going to get 6 plus or minus the square root of 20 over 2, or 6 plus or minus 2 radical 5 over 2, or in other words, 3 plus or minus radical 5. Still real numbers, but these are irrational roots. Okay, so I'm ready. My roots, x equals 2. That I knew from before. And now I have 3 plus radical 5 and 3 minus radical 5. So, interestingly enough, I have my 3 roots as expected, where one was a rational root and the other 2 were irrational, but there's my 3 roots.